Good afternoon, good evening, good morning, wherever you're at. This is Bill Wolf, and thank you for joining today's webcast with Mr. Robert here, SQL DBA with a beard. Um, my name is Bill Wolf. Just a couple of things I wanted to let you know. If you were at Summit, I hope I got to meet you. I hope Rob got to meet you, and if I didn't, I'm sorry. Uh, if you did not get a chance to go to Summit, there's already several sessions online that were recorded live at the time. And if after that, if you didn't go to Summit, then you'll have a chance to get the recordings. So you can purchase the recordings, I believe, through pass.org, even if you weren't able to attend. Um, Coming up in the wintertime, there's a little bit of a slowdown in SQL events. However, always make sure you're looking out for your local user group. Get to your local user group, go to the evening sessions, whatever, lunch sessions, get free pizza and uh, free whatever they have. I know in Virginia they're going to have a Thanksgiving dinner tonight, so several
Nice.
places you can go. Yeah, it is. It is nice. So we do the DevOps virtual user group does now have a sponsor, and that is Redgate. And I've got Stephanie here from Redgate. She is going to talk to you little bit about their involvement, and I'm going to go ahead and hand it over to her. Go ahead, Stephanie.
Great, thanks. Yeah, I just realized I might have shared my screen a little early. You guys are in the right webinar. Rob's going to be talking about PowerShell. I'm just going to spend the first few minutes to talk about Redgate because we've just sponsored this virtual chapter and really excited about getting more involved. So just real quick, my name is Stephanie Herr. I am the Database DevOps Product Manager at Redgate. I've been with Redgate for 8.5 years, always working in the database development and deployment space. Before that, I was a software engineer and database developer working with Oracle 8i and SQL Server 2000 was when I started. And I have my contact information up on the screen if you guys have any questions or want to get in touch afterwards. I wanted to run a quick poll real quick, and I'm just going to copy and paste this into the chat window. And I thought, because this is a virtual event, it might be easy to, just take a minute real fast and go over to that poll. Just curious if you've heard of Redgate before. Maybe you've never heard of us, or maybe you've used us in the past or are actively using it. So just if you could take a minute to fill out, that would be great. And just a little bit of information about Redgate. Our employees, we have about 230 people across the company. We're 17 years old. We have 202,000 customers, but even more users, over 800,000 users across the globe. We drink a lot of coffee to keep this going. 91% of our tools are used by the Fortune 100. Millions of website visits to our redgate.com website each year. We follow DevOps practices within Redgate. I think that number 139 is a really old statistic. It's much higher than this. And if you look at our roadmap, you can see, from 2010 to now, how much our release frequency has changed over the years. So before Redgate, worked in a company that was very waterfall with annual releases. I moved into an Agile Scrum teams and just haven't looked back yet, and just love the evolution of DevOps and continuing to build better software for our users, safely, reliably, listening to users and being able to respond quickly. Another thing is, we're sponsoring the PASS virtual chapter, but we also sponsor user groups, and we are a sponsor of, PASS itself, and a big sponsor at the PASS Summit every year. So if you guys were there, hopefully you stopped by and saw us. And why I'm here, why are we sponsoring, a DevOps virtual chapter? So when we talk to a lot of companies, we feel like, DevOps is picking up, and we feel like companies are getting better and better at creating an automated process around their application code. And we know this from the Puppet Dora State of DevOps report over the last few years. Deployment frequency has been increasing across teams. So people are automating, getting this message, and doing this for their application. But what we'll usually find is that the database is the bottleneck, and the database is still a siloed process. It might be a separate team. There's usually a big disconnect between the development side and the DBA and production, and it could be a bottleneck. So really, the vision for the future is having the database alongside the application code, having it as part of your version control system, integrate it in your continuous integration and testing processes, and then easily, reliably, safely deploying that out to your other environments. And still making sure, you have a DBA involved in deployments as needed, especially for deployments that are more risky. We know that the application side for DevOps and automating application deployments is increasing, but we also know that there's a huge gap in databases. So, 82% of applications have their application code in version control versus 58%. And it's actually amazing because I've been with Redgate 8.5 years, and when I've started, nobody was putting their database in version control. So I think we've come a long way, but we have, further to go. So we want to give you a reliable, scalable, repeatable process for deploying your database changes alongside the application. And there's some more information from the Database DevOps report. A lot of people are interested in this. Over 80% plan to do this within the next year, 2 years, or have already started. They really want to increase the speed of delivery of database changes. And we found that 75% of people who took the survey, we had over 1,000 people, work across both the application and the database. So that's really interesting. And again, another part of DevOps is breaking down silos and learning from each other. If you want to learn any more information about Redgate Database DevOps, go to redgate.com/DevOps. The full State of Database report is on that website. I just gave you a quick teaser of some high-level things that I pulled out. And the other thing is we have a free maturity assessment tool, so you can go in, answer a few questions, and kind of see how you compare to other companies, and also get advice on next steps on moving through the maturity of adopting DevOps for the database. If you have any questions, again, I'd be happy to answer them. And I wanted to say you'll hear more about this hopefully next month. Let's see, that we think, and you can correct me if we're wrong, we think Grant Fritchie will be back as speaking at the next chapter meeting and talking more about the Redgate solution. Thank you so much.
All right, so, and yes, he will be, unless something changes, he is scheduled to be the next speaker. So I'm going to hand this over now to Mr. Rob and make him the presenter, and we'll go from there. It's all yours, Rob.
Thank you so much. Let's see what we can see. So, with a bit of luck, what you can see is a nice screen.
There we go.
So, there we go. So we've got pretty good. I'm sat in an Airbnb in Northern England. I have been amazed this week because whenever I went out to work, the television was turned off, and when I came back home, it was turned on. I was a bit like, something funny's going on here. And yesterday morning, I worked out that somebody had set the automatic timer on television to turn on at 4:45 every afternoon. So finally, I was a little bit more relaxed. So my name's Rob. Hello, I'm known as SQL DBA with the beard. You can find me on Twitter as SQL DBA with beard. There's no A there because Twitter's only got a 15-character limit. So when I first changed my handle, I became SQL DBA with a bear, which I nearly kept. And in fact, I have now taken up as a little bit of a jokey account. But SQL DBA with beard and SQL DBA with up beard if you're going to my website. I was a production SQL DBA. I'm a PowerShell automator. I like to do things. I like to solve problems. I'm a trainer. I do some DevOps stuff with DLM consultants. You can find out about my work stuff at robsall.info. I like PowerShell automation and SQL because it's PAS. That's a terrible, terrible joke, but that's my sense of humor. I've got a beard. As you may or may have not noticed, it's quite a splendid one, if I do say so myself. I still play cricket, and yeah, I crashed my drone. It had a discussion with a tree at 40 feet, which it was fine with. It was the landing afterwards that didn't do it so good. I speak at PowerShell conferences. I speak at SQL conferences. I'm an organizer for the PowerShell Virtual Group PAS, PowerShell Conference of Europe, PS Day UK, SQL Southwest, SQL Saturday Exeter. I've written a number of modules for around SQL, so DBA reports and SQL Diag API, and I'm one of the contributors for DBA tools, which I hope you've all heard of. So, on with the show. Today's list: get up, drink appropriate liquid. We didn't learn loads at PS Day UK, I should have removed that bit. And create a continuous delivery process for delivering PowerShell modules to the PowerShell gallery. So easy, no worries. We've got 45 minutes or so to do it. We'll crack on, it'll be fun. So what we need is we need plaster. And when I'm doing this in the UK, plaster is the thing that you put around your finger when you've cut it. When you've got a little owie and you put a little smile on it so your child knows that everything's okay. But we're talking worldwide, so plaster could be the thing you put on the wall, but it's also the name of the module that enables you to build up a framework for PowerShell. So you can create a whole module from this framework. To be able to get it, you need to get onto the PowerShell gallery, and you can just type install-module plaster. You need to be running as an administrator to be able to do that, and if you're not, you just use a scope current user. We're also going to use Pester. I love Pester. Pester is a test-driven development tool, enables you to unit test your PowerShell code, and also enables you to validate your environment by returning and testing the results of any PowerShell commands. It's the first open source module that was included within a Windows product, so it will be available to you in the PowerShell you've got. And what you should do is actually update it from the gallery by doing an install module pester with a force or an allow clobber parameter, and that will enable you to update to the latest version and keep regularly updated from the new versions. There was a new version released yesterday, which is now cross-platform, so it'll work on Windows and Linux and on a Mac as well. We're going to need a GitHub account so that we can source control our code, because that's something that we all should do, and a VSTS account. So that's going to enable us to do some build and some release. None of that is going to cost you any money at all. Your VSTS account, oh yes, we won't have time for very much detail because we've got 45 minutes. So your VSTS account is going to enable you to do source control. You can put Git in VSTS as well. I'm going to use GitHub, but you can use VSTS for that. And it enables you to do the whole sort of DevOps process within your tooling, whatever you need to do. You can do your build, you can do your releases, you can do your testing, do reporting, you can work on work items, the whole thing. And it's free for 5 users. And that means if you've got a nice small team, you've got no cost at all. And does it scale? Well, I saw a tweet today that say Microsoft used, I mean, they use VSTS to develop VSTS, but they use VSTS with 25,000 developers worldwide, running thousands, hundreds of thousands of tests every day. So it will scale up to a really big, if you need it to. So why should we have a PowerShell module? So everybody starts writing PowerShell scripts. They copy some scripts off the internet, they run them, then they save them in a file, and then they change a bit everything they need to do stuff. Everybody does that. It's absolutely fine. It's not a problem. But as we get more professional with our PowerShell code, we really want to do things properly. So we want to put them in modules to enable us to make use of them in other scripts, to make them easier to share, to keep on modularity of our scripts. So we've got certain modules that will do certain things for us. And we might have Active Directory modules that help us to create our users or our computers. And we might have some modules for integrating with our DNS to work with that, or SQL Server. And it also enables us to write some code where we can export only the functions that the user needs. So we might write functions, sort of helper functions, to enable us to go and get some secrets or some users and passwords. And we don't want our users to be able to do that, but our functions need to be able to do that. And a module enables you to do that sort of thing. Why should we use PowerShell Gallery? So the PowerShell Gallery, as in PowerShellGallery.com, is a public NuGet repository of PowerShell modules and scripts. So it enables any person to share the code that they've written and for us to be able to install it just with an install module from our PowerShell commands. But we could also have a private repository that we can enable just in our own company, where we can keep some of our more confidential code available only to our users within our company. It's a really neat way of being able to share our modules, because we can simply say, register this repository and just do an install module, and it will pull down the correct module. And you can also version control, so you can then pull down certain versions if scripts only work with certain versions. It centralizes the place where you keep all your modules. So now your entire organization can actually have all of their PowerShell modules in one place. Public PowerShell Gallery is safe and secure. Now, it's the internet. Anybody can put any code in there. Nobody is guaranteeing that it's absolutely safe and secure and nothing bad is going to happen if you install it. But it does also have a lot of good malware scanning, virus scanning, all of these sort of threat scans are performed on it before it's made available to you. And again, PowerShell Gallery, we've got modules. We only need to give things to people that they need to use. So we're going to use Plaster. Plaster is, again, our framework for creating our module. So it enables us to parameterize the creation of our module. It enables us to put in some organizational requirements if we need to have those. If you're doing something more than once, you should automate it. And with Plaster, you can create the whole files, your tests, your documentation, anything that you wish to create, you can create ready for your modules. Why should we use Pester? In this scenario, Pester is about test-driven development. When you start coding in PowerShell and you're trying to use Pester, you're going to say, oh my God, Rob, this is so terrible. It's taking me ages to be able to write stuff. I can just keep on writing it. I'll get some red text. Once I stop getting the red text, then I know everything's working okay. Yeah, absolutely. You will definitely be able to code much quicker that way. But what you'll find is 3 months down the line, 6 months down the line, when another member of your team wants to start helping develop some code, when you're all starting to work together on these things and bring things forward, you'll break each other's code. And Pester will enable you to stop that. It'll reduce your time in the future. Might cost you some time now, but once you get your hang of it, it'll reduce you a lot of time in the future. It enables you to provide guidance as to how we want our scripts to be written. It enables us to support our refactoring. So when we want to recode our functions, we can see if we're failing any tests, we've broken something. Something that this code was designed to do is no longer going to work. And able to spot that really quickly. Remember, we should always want to fail early. Documentation. Everybody loves doing documentation. So Pester is now. Nobody really likes doing documentation, but Pester enables you to document how you wanted the code to behave. When I put in this parameter, I expect to get this thing coming out. So you can write that as a title of your test, and then it becomes part of the documentation of how you expect your code to behave. We can embed script analyzer and help checks so that we can make sure that we're writing good help for our functions, so we're not the support for our functions. And our script analyzer can enable us to ensure that our code is following best practices. And again, don't do something more than once. If you are going to do something more than once, then just automate it. So I think we're probably done with slides for a minute. So let's have a look at some code. So we start off with the good old question of, is the code big enough? Can you read it? And would you like me to change color? Because what I could do is change the color to something like that, if that's easier for people to read.
I'm getting no feedback, but I know me personally, I like the blue background, but I'm not getting any feedback.
Right, if the only feedback we've got is we prefer this one, then I'm going to go with that one. If somebody wants to shout, that's absolutely fine as well.
Somebody else just said it's fine, so we're good.
We're good to go. Excellent. So here's a little trick. This stops me from F5ing my entire script and breaking everything. So just put a little return at the top. If you accidentally press F5 instead of F8, then that stops everything breaking. So we're going to have a look at a plaster template. And this is my plaster template. And you can find it in my GitHub repository, github.com SQLDBA with a beard. And as you can see here, we've got some folders, a docs with the release notes. We've got a functions folder where we're going to place the code for the functions our module is going to expose. We've got an internal function where we might put the functions that we don't want our users to see. We've got a tests folder, and inside that we've got a number of tests files already with code in, so we don't have to keep writing in all of this code. And we have some more files down here. And if we have a look in our contributing file, you can see that our contributing markdown file says this is the contribute MD of our project, and then less than % equals space plaster parameter underscore module net, which is a bit of a palaver, but this is our parameter within our plaster. So you can see how you can write an entire documentation and put in as many parameterizations as you wish. All of the magic happens within our plaster manifest XML file. And you can just copy this one, or you can create one yourself. And as you can see, it's just some XML. And the XML has a bit of template metadata. And then we have some parameters. So we have a parameter block there. And our parameter blocks have things like, this is our full name, it's a data type text. We can supply a prompt. So here, please put in the module author's name. And we can also set some default values. So we can even set a default value for a different parameter that we've already set. We can write messages when we write our plaster. So we can say, I'm creating my folder structure. I'm deploying the common files. We can create folders. This is how we create folders. We set a file source, and then we say destination and the name of the folder.
Sorry, Rob, hold on.
Go for it. I'm waiting.
No, you're good. I'm sorry, go ahead.
No, okay. So we can copy our files, just copying ordinary files that don't have any parameters in them with a file source again. And this time we put the file name on this side and the destination we leave blank. If we have files that have parameters inside them, then we use a template file source. And again, we can specify where the file lives in our plaster template, and then the destination is left blank. We could also rename files. So here we take our module PSM1 file and we place it and we rename it as the parameter of our module name. And then at the end, we've got some things for creating our PowerShell module manifest file. So now all we need to do is create our module. You can literally just do it with an invoke plaster, and it will ask you for all of these questions. Where is the template? What is the destination path? And then the prompts within that plaster XML file. But we're going to parameterize these, and we're going to do some PowerShell splatting so you can see what you've got. So we've got a plaster splat, and we're going to fill in our templates. And I set them. I did set the module name. My favorite trick in this one is to forget to set the module name, and then everything goes a bit funny. So what we're going to do is going to do an invoke plaster with a verbose and all of these parameters. And I'm going to push that up so you can see what happens. Draws you some pretty pictures. The blue is the verbose output, which you don't need to see. The messages are coming out through here. So we're creating all of our files, creating our module manifest. And once we've done that, if we have a look at our module, you can see that we've created all of the folders exactly the same. We've got all the files inside. If we have a look at that contributing markdown file again, it hasn't picked up the parameters. Excellent. Thank you for that. But if we have a look at our PSM1, PowerShell extension has been updated again. You see that everything is there as we expected. Our manifest file has got a beard analysis. It's picked the version number up. We've got our author pre-filled and all of the information about our module. So, next thing we need to do is create ourselves a GitHub repository. So, we can do this with this function called new GitHub repository from Jeff Hicks, and it just takes a name and a description. And if we have a look at our module, we've created our repository in GitHub, brand new. It's all ready to be cloned, created, initialized. And as you can see, the output from the command says to push an existing local repository, run these commands. So we'll just run ourselves some git commands, and we'll sync our new repository up with GitHub. If we go back and have a look at our repository now, we've got all of our code there ready. It's just a bit GitHub, got some source control for our code. So what we're going to do is we're going to write a module to analyze the beards on this page. So as you can see, this is the Tuga team page, speaker page from this year, and there's some good beards, and Anthony, sorry mate, it's not particularly wonderful. And if we keep on going down, I think you'll see that somewhere down here, keep going there we go. There's a particularly fine beard. That looks like looks like an excellent beard. To do this, we're going to make use of a get speaker face function. If we have a look at our get speaker face function, what it does is it grabs the web page that we just looked at, and it uses the Microsoft Cognitive API faces API, and analyzes all of the faces on the page. And then it returns the attributes. So run then talk, it says, and then he talked and then didn't run. Nothing to commit. What have we done wrong there? Cannot find path git to get speaker face. Nope, that's probably true because we haven't picked up a presentations. Oh, I love demo failures. Here we go. Let's have a look.
Demo gods.
I didn't pay. So even when you pay for the demo gods, they still can bite you correctly all over the place. Chrissy Lemaire did actually. Yes, it's because I didn't run that line. There we go. See, if we don't run that line, then everything fails. So Christy told me about something about dirty power, how you can get lots of difficulties presentations because when lots of power is drawn in big environments, it can affect your laptops.
So Rob, if you don't mind, I'm going to interrupt. You do have a question.
Go for it.
Says, do you need these elements in the manifest every time per module in the pastor template already has the folder structure?
Right, okay. So,
or are these needed specific for the parameter replacement later?
Let's have a look in our plaster parameter, our plaster folder, and I will show you. So, excellent question. So, our manifest is actually created here using this new module manifest tag. So this is picked up, you've already got your destination, which version from your parameters, what your module root is, and who the author and the description is. And it will pre-create everything that's in your manifest file. So if we look at our manifest file, which I've just closed. Excellent. Bit analysis. So the plaster module automatically creates all of this for your manifest file using that module manifest tag in your XML. Does that answer the question?
He says, yep, got it.
Excellent. So let's try again. And let's load our speaker face. We're going to add it into our GitHub, and then we're going to run it in the wrong. Oh, yeah. That's why. Too much talking and not enough concentrating on where we're supposed to be. So we can't load anything there because we're in the wrong place. That's copied. Now we can add it. Now we can commit it into our GitHub. We're going to run the get speaker face command. And that takes a little minute to run because it's got to go through every one of these images and grab the information that the Cognitive Faces API can grab about each of those faces. And in a second, we're going to be able to see what we've got from there. In a little bit more than a second. No, there we go. So if we have a look at our speaker faces, you can see we've got a whole load of JSON and some names. Let's have a look at what are those objects. I'm going to pick on Yap So Jaap Brasser is a PowerShell MVP from Holland, and as you can see, Cognitive Faces API thinks that he has lip makeup on in this picture. And what we've got is just some JSON from our Cognitive Faces API. So that's what we're going to use to make sure that we can to analyze the beards on that page. So first of all, let's create ourselves a get speaker beard file, and we're going to add that into we're going to source control that. So the process when we're doing TDD for our PowerShell code is we want to write our tests first in Pester, and then we want to run them and make sure that they fail. So if we look at our first test, it says load the function, because we want to make sure that we're testing the code that we've written and not some previous code that's been loaded. We put our command name in. We won't do that in the module, but it makes sense for here. We're going to put some tests for this command name. Our test is just an it block. It has a title that makes sense, so our command name exists. And then we're going to say get command, our command name. We're going to put error action silently continue, because we don't want to, we only want to see the results of the test. We want to see whether the test is passed or failed. We don't want to see any of the sea of red because PowerShell has thrown an error in some way. And we're going to say the name of that command should be the command name that we expect. And we're going to check our input. So we want to check our parameters. Now you might think that actually if we write really good PowerShell code, then we should validate our parameters anyway. And yes, we absolutely should. But if in the future we forget that our parameter should have a certain sort of validation, somebody takes that validation off, the Pester test is going to jump up and go, oh, hello, hello. When this was first written, we wanted to validate for integers, or we wanted to validate that this was strings, or we wanted to validate that this was an IP address. So if you're changing that, you need to make sure you change the test as well. So it's just a little bit of a reminder to make sure that nothing has gone wrong. So let's run our test. Ah, the test has failed. Well, of course our test has failed, because if we actually look into our speaker beard, there is no speaker beard function. We don't have a speaker beard. And we don't have any code to test, so our command doesn't exist. So let's write some code to pass our test. We're going to have a good commit message that says, this is what I'm writing for the beard command. If there's an error message, if there is no speaker. If we have a look in here, we've now written some good code. We've got a function, we've got our parameter names. We're going to say that the faces, which equals our get speaker face. If the face name matches the speaker, sorry, if the count of the face's name that matches the speaker is 0, then return you haven't entered a speaker name that we've got. So now I can run my Pester test again. And this time it's going to run. As you can see, our Pester test is now running. It's loading our get speaker beard function that we've written, which is going to load our get speaker faces, which is going to go off to the internet, and it's going to look at the Tuga IT webpage and grab all of the faces and put them through the Cognitive API and then return us some results. And there's the problem. So it says spot the flaw. Now, if I was doing this test, this presentation where I could turn my Wi-Fi off, I'd turn my Wi-Fi off. And when I turn my Wi-Fi off and I run the test again, this test would fail. Even though I haven't changed any code at all, this test would fail. So it's really important that we write our Pester test to only test the code and not any external function. We don't want to test whether the internet's working. We don't want to test whether the Tutor IT page is up and running. We don't want to test whether the Cognitive Services API is working, or whether I've exceeded my limit of free API calls, or I'm doing it too fast. All we want to test is that our code is working. So how do we do that? Well, we'll now have a look at something called mocking. So for developers, mocking makes a lot of sense. For ops guys like myself, mocking is a bit, I don't quite get it. What we're going to do here is we're going to say, here's our test, our command name input. I'm going to say before all, that says pester command, and it says, like you expect, before all of the tests, which are the its, in this scope, which in this case is our context, please run this bit of code. And it says, create me a variable called mockface and make it the content of a JSON file with a bit of join and convert from JSON to make it into a JSON object that PowerShell understands. And then mock get speaker face with mockface, this variable here. And what that says is every time within this context that the code calls get speaker face, don't go out and call that actual get speaker face, which is going to go off to the internet and go to the Tutor IT page and connect to the Cognitive Faces API. Just instead of doing that, just return me this object. So if we run that test now, you can see that our test is going to run. And the other point of it is it actually runs much quicker because it's 16 seconds there and only 2 seconds here because it's no longer having to go off to the internet. And what it's doing is just grabbing the contents of this JSON, which as you can see looks pretty much the same as the results of the get speaker face command, because that's exactly what it is. And we look at, there's Anthony, and we have a look at his beard score, 0.4, yeah, perfectly average. Anthony is a brilliant guy. I really like him, which is why I know that I can take the mic out of his beard a little bit. So when we have lots of tests, we might find that you just have lots and lots and lots and lots of green, and you might have one red that flies up past you and you don't actually see it. You've got to scroll up and try and find it. And one way of getting around that is to look at this show command. So if we use the show parameter, then that's just going to show us all of the failed tests. You see, we've got a lot of red. We don't really know where they come from. Can't really see what's happening here. That's not as useful as making use of the fails with an S. And what the fails test is going to do is it's going to show us all of the tests that fail, but it's also going to show us the describe blocks and the context blocks. So we have an idea that when we've got a module that's got 40 or 50 commands in it, we can see that we'll have 40 or 50 of these. Here we've got some tests that pass. We know that these tests pass. We saw them earlier on, but they don't actually come up and show any output. And these are the tests that fail. So these tests are for the next part of writing our command. And what we're going to do in these tests is check that we've got an image opening by mocking a start process and a get speaker face. We're going to check, this is a way of checking to make sure our code is going where we expect it. So we've written a mock for our start process, and now we're going to make sure that our mock has been called for our start process, and we know that it's going to be called exactly twice if everything goes correctly. So these are all the tests that we're going to write. We're going to check our script analyzer rules, so we can make sure that all of our code is passing the correct best practice. We're not using aliases. We're making sure we're comparing our nulls correctly. All of the other things involved for that for every command that we've got. We're going to make sure that we've got good help. We're going to say thank you to June. We always say thank you to June. June wrote this pester test to make sure that all of your functions have the right help, because you don't want to be the person with your help. Now, normally you would build all of this up step by step by step, and you'd write a test, you'd run the test and it would fail, and then you'd write the code to fix the test, and then you'd run the test to make sure that it passes. So a little bit more about pester. We can actually run our pester and show no output at all. So whilst our test is running here, normally it runs a bit quicker. There are no output, zero output here, but we still have all of our results. We've got our results in an object, and our object has the overall count of our tests, and each test result is available in here, which we could have a look. We can save those out into a file, into XML. So now we can start building them up, making use of them within our CI build process. It just ends up as XML. So let's write our code to fix our tests. So we've written our code, we're going to add it, and then we're going to do a terrible commit message, which is going to say we're going to do all of this. Code, output, functionality, help, PS script analyzer, everything. And if we have a look, that's not what I was expecting. Don't save that. Try that one more time. If we have a look, there we go, that's what I expected to see. If we have a look at our function, we've now got some proper help, all our parameters, we've got some examples with an S, and we've got all of our function parameters. We're now going to make sure we can check for our top and bottom ranked beards. We're going to check our detailed tab. We've got a show image start process. So we'll actually commit these things in. And then we'll just quickly run our test again. And as it runs through, you can see we're checking all of our script analyzer rules, making sure that everything is working as we expect. We've got all of our help for all of our beards, for all of our beard commands, and everything is good. So that's only one command. But actually, we can write these tests, or have already written these tests, and put them into our plaster module so that we can run them for every command within our module every time we run our tests. We also need to make sure we add in our JSON file into our beard command. And now, because we've been, imagine we just test that we're working on our beard command, we can now run an invoke pester in the test folder. We're only going to show our fails, and we're going to look for commands that have for tests that have a tag of beard. If we have a look in our module and look in our tests, in our unit tests, you can see that we can put some tags in of build or unit. For our speaker beard command, we could have a tag of beard and a tag of unit. If we go further down, if we go to the help tests, you can see that we will have tagged those as help. And this enables us to just pick on the tests for the commands that we are writing, or the part of the command we're writing. So when we're writing our code, we might just want to write our beard tags. It's going to run through all of the tests, all of the .tests.ps1 files in the tests folder, and it's going to look for any tags of help, beard, and then it's going to run all of those tests. And because we've got a show of fails, it's only going to output us if we failed any commands. So our tests all pass, so our coding has been good. And then we want to check that we've written all the good help for our commands. We make sure that every test that's got a help in it has been run. That's all passed as well. And now we'd better check that all of our code has been written to follow good practice. So while that's running, interestingly, it runs against all of your tests files as well as all of your code files. I'm going to try and get my voice back a little bit. So that's going to run as testing all of our code, making sure that it's all working exactly as we expect it to. It's taking a little bit longer than normal. Still running. Ah, there we go. We've got an error. Error says the rule PS used to export for fields in manifest test. I expected 0, but was 3. So our test has failed. It doesn't really tell us very much. How do we find out what's wrong? Well, with Script Analyzer, which is included with your, it's embedded in your Windows PowerShell, you should again update it with an update module, PS Script Analyzer. You can run it against any file. So we know which file it was that it failed on. It failed on a PSD1 file. So if we run that, it says, warning, in beard analysis PSD1, on line 72, do not use a wildcard or null in this field. Explicitly supply a list for functions to export. If we have a look in our PSD1 file and go to line 71, it says functions to export's got a star. And interestingly, for this particular Script Analyzer test, in VS Code, you don't get a little green squiggle saying that this should be, this is a failing Script Analyzer test. When you're writing your other code within Visual Studio Code, you will see these little green squiggly lines, and you'll be able to highlight them and see and actually automatically fix them. But it's still good to run our Script Analyzer. So let's fix that problem. Go back, have a look. There we go. So we've actually explicitly defined our functions to export, and we've changed our cmdlets and aliases to export to empty arrays, as it says. So our code is all written. It's all ready to go. But we want to talk about continuously delivering it. And this is where we come into using Visual Studio Team Services. And it always makes me laugh because every single time I do this, whenever I go to this page, it refreshes for me. So with Visual Studio Code, with VSTS, we can create ourselves some nice dashboards showing the health of our builds and our releases. We've got a nice gallery that's showing the build process, whether it's running. We've got some graphs of how long they took, whether our releases succeeded or failed. If we look at our build process is going to run a pester test runner from the guys at Black Marble in the UK. And that's going to run all of the tests in our test folder, and it's going to export them into an XML file and put it into this place here. These are the defaults. And the reason you keep the defaults is because then you can use this publish test results plugin, which is then going to pick up that XML file and display it for you in VSTS. Then we're going to copy our files to a staging directory, which we use just to put them into a separate place. These are the place where we've got this particular one. And then we're going to publish them up to VSTS. In our get sources, we're going to link that to our GitHub. And I have to remember to turn back on my trigger. So I turn my trigger off, and I'm going to turn my trigger on. And my trigger should not be on that branch. That's very interesting. Let's go back to there, and let's change that to be, we want it to be SQL DBA with a beard. I've got quite a few repositories, beard analysis. So whenever we get a change in this GitHub repository, this is going to trigger, whenever we commit to this repository, this is going to trigger our PowerShell build to go. So once that has finished, we will have a release. If we look at our release, our release is going to be continuously deployed. So if this is enabled, so it's going to create a release every time a new build is available. So every time this process finishes successfully, this release process is going to kick in. In this scenario, we just have one environment. We've just got our master environment. And what that is going to do is going to update the version in our manifest file, because our manifest file version needs to be updated so that the PowerShell gallery will accept a new version. And we need to do a little bit of work. We need to commit our version number back into GitHub, but we need to be able to do it without triggering another build. So we need to use a 3 stars and no_CI. And then we're going to push. And because this happens in the release part, it's the Git is checked out in no head mode. We have to make use of our, we need a public access token. You need to set up within GitHub, save as a variable within your release, and then you can reference it here like this. We can update some release notes as well. Sometimes this goes a little bit funny, but this is going to take the, let me show you. This is going to take what we have written here in our release notes, and that's why it's going to go a little bit funny. So let's save that. And it's going to add in this thing. So these are the new release notes. This release has a number of important changes, and it is new, it's magical, it's better than the previous version. It really is much better. We shall see if Bill's beard is better than mine.
Now, what picture are you using? I haven't seen this yet.
we shall see. First delivered to the DevOps virtual group. So we're going to save that as well. And I'm just going to check in new release notes. Yes, please. I would like you to do all of these changes. So back to here. So we've got some changes from our release notes text file that's going to get added into our PowerShell gallery. And then we need to commit those. And then simply we run this bit of code, which downloads NuGet if it's NuGet.exe if it's not available. And with a little bit of error handling, then simply publishes our module to the PowerShell gallery. So let's have a quick look in the PowerShell gallery. We'll look for bid analysis. There we are. And see, currently we're at version 0.9.25. That one was first demonstrated in Singapore on the 15th of October. So let's go back to our demo. I'm not going to do that because I've already done that. We've committed that. Let's push to the gallery. Sorry, push to GitHub. So we're going to push all of those changes we've made into GitHub, and as soon as those have gone through, when we go and have a look at our dashboard, we can see we've got a build. See, every time refreshes. We have a build going. Our traffic lights are going to be going red, yellow, green. It's doing yellow. It's waiting for an agent, and that'll start running through. If we go and have a look in here, you could actually watch it go through. The moment we're waiting on an agent, once the agent starts to come through, you'll be able to see the progress of it running through down here, and then it would go through and do a release. So whilst that's going through, let's just have a look at our bid analysis. We're going to use the old version. I'm sorry, it's not quite as good, but we're going to just run it against Rob's tool. Let's see what we get from there. See if we get anything useful from that command. See if our build is going through. Oh, there we go. That's our detailed image. There's my image, and I've got a bid score of 0. Oh, okay. Let's have a look at the top 5. Have a look at the top 5. Top 5. That's it's a bit odd. Why is that a 0? It's not looking good. It's not looking good, Bill.
Too much gray.
Too much. Could very well be too much gray. So let's have a look. So Lonnie's got a 0.8. We'll have a quick look at Lonnie's. Let's see what he's got. It's very odd. I'm not very happy about this. Let's go and have a look and see if our build's going through. No, we're still waiting on an agent. The beauty of using Visual Studio, team services, hosted agents is sometimes you have to sit and wait. There we go. So hang on a minute. So that's 0, and that's 0.8. No, I tell you what, something's wrong here. Tell you what, I've created this little function for fun, and what we're going to do is we're going to look at Rob's beard, and here's my beard. So I think you see that's a pretty stunning beard, and we'll compare it with Bill's beard. So let's have a look at Bill's beard. Yeah, I mean, equally quite a stunning beard, sir. I think I'm very impressed with that.
Thank you.
Let's just have a look. So if we have a look at Rob's beard, yeah, the beard score is 1, and you'll be pleased to see no makeup. What do you reckon, Bill?
What am I going to get? I should get at least a 0.9.
0.9. Sorry, I'm afraid you got a 0.8.
With Lonnie, the same as Lonnie.
You have got the same as Lonnie.
There's
according to it is merely the Microsoft Cognitive Faces API, my friend. I cannot take responsibility, but I'm equally I'm very pleased to see that you're not wearing makeup as well.
I hope not.
So, what a shame. Normally, by the time we've done that, our hosted agent has run through, we've done a build, we've done a release, and we can go and have a look at this, and we'll see that our release notes will be updated. So in a while, if you go back and have a look, just search the PowerShell gallery for beard analysis, see that it's changed to 0.26, and have a look at the release notes, and you'll see this process has gone through. But unless it's magically started working, current queue position is number 1. So what we'll do is we'll go back to our slides, and we'll say, look at the summary. Continuous delivery for PowerShell module to the PowerShell gallery is really easy. You just need to use Plaster to template your module framework, to create all of the files and folders and parameterize them as you need. Use Pester as a unit testing framework for your PowerShell code. Write your tests, run your tests and see that they fail, and then write the code to pass your tests. VSTS is free. The plugins that we've used all the way through, they're all free. You can make use of those today, have some fun, create some modules, write code that you can enable for other people. I'd like to tell you that at the moment, DBA Tools is working towards making this process work for CI, CD to the PowerShell gallery, and I am trying to get it to work for William Durkin and Emeric van der Laar's open query store module for SQL Server as well. So shortly we'll be able to be doing that. So already this process is in use. If you have any questions, feel free to get in touch with me. I'm at SQL DBA with Beard or via my website. Unfortunately, we're still waiting on somebody else to do some magic in VSTS. But that, unless we have any questions.
The only question I had was from Hiram earlier, and he answered it. So, or you answered it, I'm sorry. Is that anybody we know?
Unfortunately, it's not. It's just a random picture off the internet. But
that is fine.
I found it many years ago, and it does just make me laugh so much.
All right, so I do need to give out a gift card here. Now, I'll get the person's information after I do. However, I don't know. Maybe you could ask a question and see if anybody wants to answer it, and I can get them a $75 Amazon gift card.
Well, I mean, I think the person who asked the question about the module manifest would be an absolutely perfect person. That was an excellent question, and really helps to bring out some more from the presentation. So yes, I would say that person.
Well, he seems very happy, so he says, "Woohoo! Thank you."
You're welcome.
All right, Hiram, I'll get in touch with you here in a second. So. All right. Well, thanks so much, Rob, and thank you guys. And real quickly, I've been communicating with Grant Fritchie while we've been on this. So next month, December 14th, it's going to be at 11 a.m. Eastern, which, Rob, that's 4 p.m. England, right? You're
5 hours, yes.
It's 5 hour difference, so it's 4 p.m. England, and that's 8 a.m. West Coast here in the U.S. So... and Hiram says he'd like to see more of these presentations. This is being recorded, so I'll put it on the recording. And Rob, if you can send me the slides, if you haven't already, I can make them available too.
The slides. So if you would like to get the slides, can you still see my screen?
Yes.
Excellent. So my slides, these slides, and every other slides I do, if you go to github.com, SQLDBA with a beard, there's a presentations folder. You'll find all of my presentations, take all of my code, make use of it, do whatever you will. And this one is under PSA UK 2017, because that's where I first did it. And there is all of the code, all of the demos, everything for you to see what's been happening.
All right, sounds perfect. Well, thank you very much, everybody. And Hiram, I sent you a message, but you guys can... If you want to just DM me on Twitter, that's perfect, and I'll get you the information from there. All right. Thanks, Rob. Thank you so much. We'll talk to you guys all later.
Okay. Thank you.